What is up, you guys? It is good to see you. We are on page 340 talking about isosceles, triangle, base angles theorem. Make a note card, right? Make a note card, and on that note card, put the definition that's on the bottom of page 340 just to kind of get ahead of the game. And then maybe even perhaps draw this diagram on this note card, which I'll do off camera, but I want to let you know that I want you to have that ready to go for today. You're also going to need some tracing paper because in our tracing paper, we're going to use that. Have a ruler. We're going to use a ruler of some sort with like centimeters or inches, whichever you're best at using for measurement, and then something to write with. A question I'm going to ask you along the way that I want you to think about it is, how can the proof of the perpendicular bisector converse theorem help us with this proof? And if you have it, look for it, go back to the previous page, and figure out what you needed to do for the perpendicular bisector converse theorem. Let's get into this one. I've got these note cards to use today too. I've got given, I've got reflexive property, I've got CPCTC, and I also have, perpendicular bisector converse theorem and the isosceles triangle base angles theorem. You should find those note cards out of your stack as well if you're following along and using that as a suggested study guide. Well done. Highlight, here we go. Highlight the habits of mind. In this video, we're going to talk about how you can reason abstractly and quantitatively. We're going to construct viable arguments and critique the reasoning of others. You know, CPCTC, corresponding parts of congruent triangles, makes it possible to prove other theorems also, like this one. You have explored the relationship between the sides and angles of an isosceles triangle. An isosceles triangle really does mean that the two sides of that triangle are the same. Not the third. You can't have one by itself, congruent to itself. Two sides of a triangle are the same. Specifically, you conjecture that if two sides of a triangle are congruent, then the angles opposite these sides are congruent. So like in our picture, we're going to consider the diagram to write a paragraph proof. Now, I'll pause for a minute, and I'll share with you the Mad Lib that I want you to use for this. It's the game, right, you play, where you make up words. We're going to make up specific words, and so let me go ahead and move my video face out of the way and say, please copy down this Mad Lib with the blanks. We're going to fill in these blanks during the course of this video. Okay, pause the video here, and then come back in like 3 seconds of video time to help fill them in. All right, we're back. You're back. Hey, what's up? Let's go ahead and do the math for this video in order to answer the question. So back in the diagram up here, a little zooming out, little adjustment. It says that we are given some information. We're given that GB is congruent to GB. So we're going to add to the diagram that information. Okay, that might include putting in some spikes, right? GB is this line segment, so put a spike on it. And then GD is this line segment, so put a spike on that. Those two line segments are meant to be congruent. They're the given. Givens are always highlighted yellow in my videos, so I'm going to highlight them yellow. And we're going to prove that angle B and angle D are actually congruent. So this is my pink prove it, which is what we will do eventually. Again, add color, right? Add color to your diagram so that you're able to kind of process what actually is happening throughout each step of the proof. Now, before we actually fill in the blanks, I'm going to say we're going to construct the midpoint of dB, and I'm just going to measure it, right? I'm going to use centimeters, millimeters, and I'm going to measure how long dB line segment is, and then I'm going to divide by 2, because if it's a midpoint, it should be in the middle. I get from lined up here to lined up here, I get 1, 2, 0.1, 0.2, 0.3, 0.4, 0.5. Those are all millimeters, right? 1 centimeter, 2 centimeters. Here are the millimeters, 1, 2, 3, 4, 5, 6, 7. I get 2.8. 2.8 centimeters, or 28 millimeters, same measurements, just different ways of converting it. Divide 28 by 2, you get 14. Or divide 2.8 by 2, you get 1.4. So I want to make a mark at 1.4 centimeters. 1, 1, 2, 3, 4. Make it a little bit bigger. I'm going to label that as M. All right, now while I'm still on the diagram, I'm also going to construct the line GM. Okay, pretty accurate. Could be more accurate, but there it is. That's our diagram. Ready? Let's go ahead and fill in the blank now, given that that diagram is here. And so I'll kind of slide back and forth, but you can also go back to this minute in the video just to remember what the diagram looked like. Okay? Given this information, here we go. So given what was stated up above, was GB is congruent to GD. We always need to report the given. You have to. Okay, start with the given. Now, locate point M as the midpoint of our line segment DB. Right? And then construct GM. Those are the first three blanks. That's what we did. And so none of that requires another card. It's just how we're showing the construction of our diagram. This is going to create a triangle. It's going to create triangle GDM, and it's going to create triangle GBM. All right, so we got these two triangles that are created up above. Since we have triangles, and we have these lines that are highlighted yellow, and we've got this line that's in the middle, and also I can put a little label here. That's 1.4 centimeters, and this is 1.4 centimeters. So therefore, these two segments are the same. We're going to add that information down here too. Okay. This means GD is congruent to GB, and DM is congruent to BM because we did that, they're given. Also in the diagram, look right here, the top triangle has GM for its third side, and the bottom triangle has GM for its third side. So actually, GM is the third side of both triangles, and it is ending up to be congruent to itself because both triangles have GM as a feature on them. And that's, of course, by the reflexive property. So we're going to use the reflexive property to say this line segment of the top triangle is the same line segment as the bottom triangle. So triangle GDM is congruent to triangle GBM. And the reason that it is because of side, side, side congruence. Finally, by CPCTC, the thing that we're trying to prove is that if the top triangle and the bottom triangle are the same, then any other pieces in the triangle are the same, like these two angles. So therefore, the thing that we needed to prove by CPCTC is that angle B is congruent to angle D. That's what we needed to prove. Here's what we started with in order to be able to do the proof. So therefore, we have a completed proof. When you finish a proof off, you get to put a little like box at the end of it. All right, there's several different ways to say a proof is finished, and a box is one of them. You guys, that's it for this video. We're going to go ahead and acknowledge that page 341 is next. We're going to talk about the converse of the isosceles base angles theorem. You should look at the bottom of this page for the definition of the isosceles base angles theorem. If two sides of a triangle are congruent and the angles opposite, then the angles opposite those sides are also congruent. See you in the next video. Thank you for watching this one.